Hello my dear students of grade 9. Welcome to today's lesson, that is nature and properties of matter. That is the third lesson of your grade 9 science textbook. You all are familiar with this concept. Now if you look around yourself, that is your environment. What are the two main components of the environment? The living organisms and the non-living components. And again, if you take the non-living components, how can you classify them? You can classify them as matter and energy. And in this lesson, we are going to concentrate on matter. So, we are trying to understand the nature and properties of matter. To do that, we will be classifying matter into other components. Let's look at the content. So, as I said before, under matter, we will be looking at elements, the most simplest forms of matter that has a definite property. And you are familiar with that, you have identified it as pure substances. Same goes for compounds. When elements, atoms of elements combine and form the compounds, again they are pure substances with certain properties. Then we have mixtures. If we look at our environment, we don't always get pure substances. Instead, there are many substances mixed together. That is how we get the mixtures. So, we will be discussing all three: elements, compounds and mixtures in this lesson. So, with that introduction, I will move on to the lesson. So, to start the lesson, we will try to answer these questions. These are questions that you have already discussed in your previous grade. So, you all know what matter is. What is matter? How can you answer that? Anything that occupies space and has a mass is known as matter. So, that is what you have to write here. Substance. You can say substance or anything that has a mass and occupies space is known as matter. Then, you all know the three states of matter. The physical state in which matter exists. For example, if we take water, water can be in the solid state, that is ice, and normally it exists as the liquid state, that is water, and when you boil water, it becomes the gaseous state, that is water vapor. So, for any substance, or you can say matter, can exist as a solid, liquid or a gas. And those three are the physical states of matter. So, what are the states of matter? So, we can answer as solid, liquid and gas. Then, the next question. Again, that is something that is familiar to you. The discontinuous nature of matter. You all have discussed this before. Now, if you take any substance, whether it's ice, water or water vapor, you know they are all made up of particles. And those particles are known as constituent particles. So, based on that, we say matter is discontinuous or the discontinuous nature of matter. You have done many activities before to understand this nature. So, what is that? Matter existing as constituent particles with spaces among them is known as the discontinuous nature of matter, or what we call as particulate nature of matter. So, that is what we have to write here. What do you understand by the discontinuous nature of matter? So, we can say matter is made of constituent particles with space among them is known as discontinuous nature or particulate nature of matter. So both refer to the same concept, discontinuous nature or particulate nature of matter. And then the main concept of this lesson, how do you classify matter? How did you all classify matter? Initially you classified it as pure substances and non-pure substances. From now onwards, you can also refer to the non-pure substances as mixtures. So that is how you classify matter. So here we can classify matter as two main components. That is pure substances and non-pure substances. So, under pure substances, we will be discussing about elements and compounds. And under non-pure substances or mixtures, we will look at two types, the homogeneous mixture and the heterogeneous mixture. So these are the substances that we are going to discuss in more detail. What elements are and what are the constituent particles of elements. Under that we will discuss the structure of atoms, then how compounds are made by the chemical combination of atoms of elements, and the two types of mixtures. So is that okay, students? So I hope you all have an idea as to what we are going to discuss in this lesson. So we started off by answering these questions to which you already know the answer. What is matter? Substance that has a mass and occupies space is known as matter. And the three states of matter, solids, liquid and gases. Then what do you understand by the discontinuous nature of matter? So matter is made of constituent particles with space among them. That is known as discontinuous nature or particulate nature of matter. Then again, this is how we classify matter. So matter is divided as pure substances and non-pure substances, and under pure substances we have elements and compounds, and under non-pure substances, which are known as mixtures, we will be looking at homogeneous mixtures and heterogeneous mixtures. So with that, I will move on to the next slide. Here we have an activity. The first activity in your textbook, activity 3.1, classify and tabulate the substances given below as pure substances and mixtures. So, as I told you, the non-pure substances are now referred to as mixtures. So, how do you identify that? Just by looking at the name, sometimes you can. For example, let's say if you take something like carbon. Now, carbon, you are familiar with that, you know it is just one substance. So, you can identify it as a pure substance. But say something like water or let's say air. From the name only, can you all identify whether it's a pure substance or mixture? No. You need to understand their properties. So, that is what we have to do here. So, let's look at each of these substances given. Now, first one is air. Now, when you say air, that is around us in atmosphere, what are the constituents of air? You all know that there is nitrogen gas, oxygen gas, carbon dioxide gas, and even water vapor and other components in air. So, there are many components, many constituents. So, that means it is a mixture. So, air is a mixture. Why? You can say there is nitrogen. This is for your understanding, students. Nitrogen, then there is oxygen, carbon dioxide. So, like this, there are other components. So, then the drinking water is also a mixture. Drinking water. Why? It has water and minerals present in it. Then what do we have? We have aluminium. Aluminium, of course, is a pure substance. So, that comes under pure substance. Aluminium is pure substance. Then what do we have? We have silver. Now, that is also a pure substance. After that, copper, that is also a pure substance. Now, if you take all these three, aluminium, silver and copper, you know they are all metals. You would have seen them. At home, we have all these metals in different forms, maybe the aluminium frames, you might have seen silver jewelry, then copper in copper wires. So, you are somewhat familiar with those substances. So, those are pure substances. So, then if we take the second one, it's silver and then we have copper. What is the next one? Salt solution. So, from that name itself, you can identify. It says solution. So, that means there has to be more than one substances. Salt is dissolved in water. So, that has to be a mixture. So, salt solution. So, that is salt and water. Again, students, as I said, you don't have to really memorize these, but when you know what the components are, it's easy for you all to remember or classify them as pure substances and mixtures. And also, you're familiar with all these components. Then, if we take distilled water, now that is different. Why do we say distilled water? There, we remove all these other minerals and other components from water. So, that is only pure water. So, that will come under pure substances. Distilled water. So, we have distilled water here under pure substances. Distilled water. So, then we have carbon. So, you all know what carbon is, students? It is the carbon lead of the pencil. So you all know it is a blackish color substance and that is a pure substance. You all have to know that. So carbon is a pure substance. It comes under pure substance carbon. Then we have the next one, sulfur. Sulfur is also a pure substance. If I will show you all in the lab, it is a yellowish color crystalline solid substance. So that is again a pure substance. That is an element. We will discuss that. It is an element. So sulfur again is an pure substance. It is a pure substance, sulfur. Then we have zinc. Zinc is again a metal. So that is also made up of one type of constituent particles. So that again is a pure substance, zinc. Zinc is a pure substance. After that, we have copper sulfate. Now, copper sulfate, you might think, okay, there are two names combined. So, whether it's a mixture. No, it is one substance. It is a compound made up of copper and sulfate substances bound together chemically. So, that is one particular compound. It has only one set of specific properties. So, therefore, copper sulfate is also a pure substance. So, copper sulfate, you might have seen that in the lab. A blue color, solid, crystalline, solid substance. So, copper sulfate is a pure substance. Copper sulfate. Then we have the last one, sodium chloride. Now, sodium chloride again is similar. It is made up of sodium and chlorine, but it is a compound and it is a pure substance. So, sodium chloride is again a pure substance. Sodium chloride. So, you can see here, students, we have classified all these substances as pure substances and mixtures. So, out of those, you can see air is a mixture because it is made up of components like nitrogen, oxygen, carbon dioxide, water vapor. There are many components. So, it is a mixture, not a pure substance. Then we have drinking water, water and minerals together. So, that means again that is a mixture. Then we have silver, copper. Those two are, you can see, pure substances. Only one type of constituent particles. Then we have the salt solution. So, they are salt solution, salt and water. Again a mixture. Then we have distilled water. As I told you, only water molecules. So, only one type of constituent particle. So, distilled water is a pure substance. Then after that, we have carbon, we have sulfur and zinc. Those are all elements, what we will be discussing as elements. So, they are again made up of one type of constituent particles. So, those are again pure substances. Only carbon particles, only sulfur particles, only zinc particles. Then the last two, copper sulfate. So, copper sulfate is a compound. It is made up of only copper sulfate constituent particles. So, that is a pure substance. The same way, sodium chloride. So, only sodium chloride particles are there. So, that again is a pure substance. So, all these are pure substances. These are mixtures. But from this again, although they are made up of one type of constituent particles, you can understand aluminium, silver, copper, carbon, sulfur, zinc. They are made up of just one type of element. So, that means they will be coming under elements. Under pure substances, there are two types. So, those are going to be elements, whereas distilled water, copper sulfate, sodium chloride, they are made up of more than one elements combined chemically. So, they will be coming under compounds. That is what we will be discussing a little later. So with that introduction, I will move on to the next slide, where we look at matter and the types. So matter that contains only one constituent with specific properties is known as pure substances. So I explain this one constituent. Then there is another thing, specific properties. What does this specific property mean? Now we said carbon is a pure substance. I said pencil lead. What are the properties? It is a solid, you can write with it, it's black in color, it has a shine. Those are all properties of carbon. So specific properties. Then I told you all copper sulfate, blue in color, again solid. Then water, it has certain properties. It's a liquid, colorless, odorless, tasteless. So that has certain property. So like that, matter that contains only one constituent with specific properties is known as pure substances. So all of them are pure substances. And pure substances are further divided as, I told you all the two types, elements and compounds. So here they are divided as elements and compounds. Then, matter that contains two or more constituents are known as mixtures. We have discussed that also. Matter that contains more than one constituent or two or more constituents. Is that clear to you all? So, for example, air, many gases are present. Then if you take drinking water, water plus minerals are there. Salt solution, salt and water are there. So, two or more constituents or more than one constituents. That is a mixture. So, with that, now I will move on to the next slide. Again, another activity. Now, here you are supposed to classify and tabulate the following pure substances as elements and compounds. Everything that is given to you are pure substances. So, they have mentioned that here, pure substances. So, you need to divide them or classify them as elements and compounds. So, this is again somewhat tricky. As I told you, from the name, sometimes you can identify whether it's an element or a compound, but sometimes it's difficult to identify. So, let's see. The first one, sulfur. Now, sulfur, it is made up of only sulfur particles. So, that is a pure substance, that is an element. So, sulfur is an element. Then, the second one, glucose. So, here is the tricky part. Glucose, you know glucose and you know that it is a compound. So, because of that you know. But that again, you can't decide from the name. Glucose is a compound. Because this is made up of different elements. Now, we will be discussing that in a while. You will understand glucose is made up of carbon. That is one element. Then there is oxygen and hydrogen. So, three different elements make up glucose. So, therefore, it is a compound. Once we discuss that in more detail, you will understand it better. Then look at chlorine. Chlorine is a pure substance. It is an element because that's made up of only one type of constituent particles, chlorine. So, that comes under elements, chlorine. Then what do we have? We have sodium chloride. So, there from the name you can identify. It says sodium and chloride. So, that means there is sodium and chloride bound together. Chlorine bound together with sodium. So, that is a compound. Sodium and chlorine give rise to sodium chloride. So, here The constituents are sodium and chlorine. Then we have silver. What is silver? We already discussed it's a metal. So that only has silver constituent particles. So that is an element. Silver. Then after silver we have copper. So copper. What is copper? Again a metal. So that is made up of only one type of constituents. That is again an element. Copper. Then we have copper sulfate. So again there from the name you can identify it is a compound. Why? There is copper and sulfate, but sulfate is again made up of sulfur and oxygen. So copper sulfate, it is made up of copper, sulfur and oxygen. So many elements combine together by chemical methods. So that is a compound. Then we have zinc. That is the last one. That is again is a pure substance that comes under element, zinc. So zinc is an element, only one type of constituent particles. So this is how we classify these substances. Is that okay, students? So here sulfur is an element, glucose is a compound, chlorine is an element, sodium chloride is a compound, silver, copper, they are elements, then copper sulfate is a compound and zinc is an element. So that is how we classify these substances. With that classification, now that you are familiar with these substances, it's better if you can have an idea as to how they look like. You might have seen some of those already, but we will go to the lab and try to look at all these substances, the elements as well as the compounds. Okay, students. So now we are going to observe the different types of pure substances. So you all know how to classify pure substances and non-pure substances. So what I have here are all pure substances. So again, how do we classify pure substances? As elements and compounds. So as examples for elements and compounds, I have all these substances. You can see here, this is copper. And you can see with the name, I have also mentioned the symbol, chemical symbol, because we are discussing that with the lesson as well. So here you can see copper. This is the copper metal. You can see the nature of the copper metal, reddish brown color, the shiny nature as well as the metal pieces. So you can observe that. Then here we have iron. Iron is present in the form of black color powder here. Normally you all know the iron objects which are made up of iron. They are solids. Here it is the iron powder that is shown to you and the symbol is Fe. Then here I have another element that is sulfur. The symbol is S. And here you can see that again is a crystalline solid substance, yellowish color, crystalline solid substance. And here students, can you all see this one? This is mercury. So here students, you can see this again is an element, mercury. The symbol is Hg and you can see it's a liquid metal. You have to remember it is an element, it is a metal and it's a liquid metal. So when I move the petri dish, you can see the movement of mercury. That is because it has a high density as well as it is a metal. It has certain special properties. So that is mercury, again an element. Then we have here, this is carbon. Carbon, you're familiar with carbon. In lead of pencils, we have carbon graphite. So here also again it is a black color substance. There are different forms of carbon as well. So this is again an element. So then we have aluminium, Al. That is again a silvery shiny metal, an element. So that is aluminium. So all these, now these 5, copper, iron, sulfur, carbon and aluminium, they are elements and they are all in the solid form. Here mercury is again an element, it is in the liquid form. Then I have here the chlorine gas. So now here students, can you all see that now I have taken 2 boiling tubes so that you can compare. This is on my left side, it is an empty boiling tube, and on my right side you can see that is the boiling tube that contains the chlorine gas. So you can identify it as the greenish yellow color gas. So normally students, we don't prepare this in a very large amount because it's somewhat harmful to the health of us. So because of that, only a small amount has been prepared, but I am sure you can observe the color there. So that is also an element. So as you can see students, the pure substances, the elements, they can exist as either as solids, liquid or a gas. So those are the elements, one type of pure substances. Then I have another 3 substances here. They are also pure substances, but they are compounds because they are made up of more than one elements. So here you can see copper sulfate. You can see the blue color crystalline nature, that again is a solid. So that is copper sulfate. Then we have sodium chloride, NaCl. So NaCl is the common salt, sodium chloride, that is available in our household as well. Those are white color crystalline solid substances, sodium chloride. And here glucose is something that you are familiar with. That again is a white color solid substance. So that is also something you all know. So copper sulfate, CuSO4, sodium chloride, NaCl, and glucose, the chemical formula is C6H12O6. So you will be introduced to all these atomic, the symbols as well as the chemical formula in this lesson. So that is why I have written down all the formula here. So from this, I am sure you all can understand that there are non-pure substances like the drinking water, sea water, all the different types of substances which are mixtures, and then we have the pure substances. Under pure substances, we have the elements and the compounds. Okay students, so did you all understand? You all had a look at all these elements and compounds. So you have an idea as to how they look like. And also you have to understand how we can classify them as elements and compounds. So with that, I will move on to the next topic. So then we will discuss what elements are. So you already know they are pure substances. So that means they are made up of just one type of constituent particles. So if we look at what elements are, the pure substances with specific properties, so that is one term you have to understand, which cannot be further divided by either physical or chemical methods into substances with different properties are called elements. So we'll try to understand that. Now let's say we have carbon. Now I told you all, we saw some examples. We saw carbon, then we saw copper, like that. We saw some examples. Carbon, because you have it with you. If you take the pencil lead is made up of carbon, so you know what that is. Now this carbon has specific properties. What are the properties we discussed? We said it is black in color, then it has a shine, then you can write with it, and also you're familiar with it, it can conduct electricity. So conduct electricity, and also at room temperature it is a solid. So these are some specific properties of carbon. In addition to that, there are properties like melting point, boiling points, which you will discuss later in your other grades. But for now, just remember there are some specific properties. Similar to that, if you take copper. Now, copper is a reddish brown color metal that also has shine. If you drop it down, copper makes a sound, the sonorous sound. Whereas carbon, if you drop it down the pencil lead, it breaks. So that's brittle. So you're familiar with all these properties of matter. So thereby we can say they have specific properties. And the next point, which cannot be further divided by either physical or chemical methods. What are physical methods? Now when we say physical methods, what are these physical methods? Say by heating something, if you provide heating. Or let's say drying something. They are all similar. Vaporizing something, reducing the temperature, trying to get it to a solid. All these methods are physical methods. Now, if you take this carbon, put it into water, or if you just heat it in a flame, if you just try to burn it in a flame, still you can't convert it into another material. So that is what we say by physical methods. You cannot separate them further into substances with different properties. It will undergo a chemical reaction and will become a completely different substance. It might become a compound, it might become a mixture, but you cannot make it into another element. So let's say we take carbon. We take carbon and let's say we hold it to the fire. You are trying to maybe melt it and convert it into other substances with special properties or specific properties. That will not happen. Now carbon might get converted to another chemical substance, but it will not get divided into substances. So that is what you need to understand. By doing a physical method like heating, drying, evaporating, dissolving, you can't convert it into substance with different properties. The same way, when we say chemical methods, those are the different chemical reactions or chemical changes. That also will not convert carbon to simpler substances with different properties. You cannot divide carbon. It will be a different substance, not divided into smaller substances or simpler substances. Do you all understand that? So those type of substances are known as elements. So here you all can see, if I read it again, the pure substances with specific properties which cannot be further divided by either physical or chemical method. So when you take carbon, there will be only carbon particles. So you cannot divide them. If you try to do that, they will become some other substance. You cannot divide. That's the important part. So then we call them as elements. Now let us look at some elements which you have already seen in the lab. I showed you all these elements. So you can remember looking at copper. Copper, the reddish brown color metal. You were able to identify the shine and all that. Then iron. Iron was like a black color powder. And you all know the uses. Copper is used as copper wire to conduct electricity. Then iron, although we don't use it as iron powder, you might have seen that in the lab and when I showed it you all. But at home, you have lot of things that are made up of iron. So you're familiar with that element. Then sulfur. As I told you, in matchsticks and all those, they use sulfur. It is a yellow color, again a crystalline like, shiny like solid. So that is sulfur. Then mercury, you have seen that in thermometers, you saw it in the lab. That is a liquid, but it is a metal. Again, mercury. Then you saw carbon. Carbon, you all know, it's a black color solid powder, and even the lead of pencil, that is also carbon. So, that again has a different property. Then if you take aluminium, a metal with a silverish eye, that also is familiar to you. Sometimes we have aluminium frames, things made up of aluminium at home. Then silver. Silver is also a silverish shiny metal, but you can differentiate aluminium from silver. By looking at it, if you have seen those, you will be able to identify them. Then take chlorine. Now, chlorine again is an element, but it was a gas. You were able to see this yellowish green color gas. So, I showed you all with the paper behind it and with comparing to the empty boiling tube, so that you will be able to identify the color. We don't make lot of chlorine because that can irritate our respiratory system. So, because of that I didn't make a lot, but you were able to have a look at it. So, these are all elements, and as we discussed, they all have specific properties. You can see the difference in color, difference in their physical state, solids, liquid, gas, and they do different functions. Now, carbon graphite can conduct electricity, these metals can conduct electricity, and they have different uses. So, like that, they all have specific properties. And if you take all these elements, they are made up of one constituent component. For example, sulfur. Sulfur cannot be further divided into other substances with specific properties by physical or chemical methods. So, all these are elements. That is what you have to understand. With that, I will move on to the next slide where we discuss compounds. That again, I showed you all in the lab. You were able to see glucose, then copper sulfate and sodium chloride. So, as I told you, now glucose is made up of carbon, hydrogen and oxygen. So, three different elements combine to form one particular compound, and in that the elements are chemically combined. So, that is why you get glucose with special properties. You know, we take glucose, we consume glucose when we need energy, when you are doing sports activities. So, or if you are not well, then we take glucose. So, that is a substance that we can consume. Whereas copper sulfate, you have seen that, a blue color crystalline solid substance. So, that is copper sulfate. Then sodium chloride again, we use it for cooking. So, that has a salty taste. Glucose has a sweet-like taste. You know the difference. So, like that, all these three compounds, they also have specific properties. But they are made up of not just one element, but many elements or more than one elements combined chemically. So, let's see what these compounds are. The compounds are pure substances with specific properties that I told you all. Glucose is only glucose, copper sulfate is only copper sulfate, sodium chloride is only sodium chloride. That is pure substances with specific properties formed by the chemical combination of two or more elements in a fixed ratio. Now, just remember this for now. When we say fixed ratio, we will be writing chemical formulae for these. You will understand then. If we take sodium chloride, the simplest one, there is just one sodium is to one chlorine. So, the ratio is 1:1. So, here sodium is to chlorine is going to be 1:1. So, that is what they mean by fixed ratio. But if you take copper sulfate, we will look at the chemical formula. It will be CuSO4. 1 copper, 1 sulfur and 4 oxygen. So, the ratio is going to be 1:1:4 and that is going to be fixed. Then if we take glucose, it will be carbon is to hydrogen is to oxygen. That is going to be 6 is to 12 is to 6 or 1 is to 2 is to 1. So, they are combined in a fixed ratio. Can you all understand that? So, if I read it again, the compounds are pure substances with specific properties formed by the chemical combination of 2 or more elements. So, here there are 3 elements. Here also there are 3 elements. Sodium chloride, 2 elements, 2 or more elements in a fixed ratio. That is what we call as compound. In nature, there are very large number of compounds which occur from the combination of various elements in various forms. Now, I said in glucose there is carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen can combine in many ways. Even sugar, that is sucrose, that also has carbon, hydrogen and oxygen. And there are many other substances that have carbon, hydrogen and oxygen. So, they can combine in various forms. So, that is what is given here. So, in nature, there are very large number of compounds which occur from the combination of various elements in various forms. So, different ratios, different forms, different elements that gives rise to so many different types of compounds. Is that clear to you all students? So, with that, I will move on to the next slide where we again look at elements, and under this we will try to understand how we give symbols to elements. Now, if you take all the places around the world, now you all know we use different languages. So, for elements, if we use different languages, it will be very difficult in the world of science. For scientists to compare and understand, learn about elements, it will be difficult. So, to avoid all these confusions, what they have done is, they have proposed a method of naming the elements as well as giving symbols to elements. So that when you write, now instead of writing carbon, if you use a symbol, it is easy to denote the carbon. So that is why we need symbols for elements. We know that in various instances, we use various symbols to facilitate communication. You are familiar with that technique. Road signs are there are other symbols, danger signs. So, that gives more information within a short time. Very quick to understand. If you see a danger sign, you know, okay, you shouldn't go there. Without a person telling you, you can understand. So, similar to that, if we can give a symbol to an element, it is easier to get more information. So, symbols are used to indicate elements as well. All countries in the world use these internationally accepted symbols to indicate elements. So, they have to be internationally accepted. That is what I told you all. Now, for our country, if we have one type of symbol, another country has another type of symbol means, then again there will be lot of confusion. So, here these are symbols that are internationally accepted. All around the world, it is the same symbol. So, scientists have agreed on that, then they have given symbols to all the elements. And I think you all know about this. There are about 92 natural elements. That is, they are in nature. They have formed in nature. So, those are the natural elements. There are about 92 natural elements. Natural elements. But there are other synthetic elements also. So, at the moment, there are about 115 elements that are present, but out of those, 92 are natural elements. So, in order to study about all these elements, it is easier to have symbols. And when we assign symbols, there are certain rules or things that you need to consider. You can't just randomly give them symbols. It has already been assigned and according to a certain method. That is what we are going to discuss next. So, if I move to the next slide, these are some guidelines you have to remember. Based on these guidelines only, they have assigned symbols to elements. So, the first one, very often English name of the element is used as the base for these symbols. For example, like carbon, hydrogen, all these magnesium, these are all English names, names of the elements. So, then what they do is they use the first letter of the name. In such case, the first letter of the name of the element is used as the symbol. A very simple guideline. And when a single letter is used as the symbol, compulsorily it should be a capital letter. So, it is compulsory to write it as a capital letter. One letter, it has to be capital. Or if there are more than one letters, the first letter has to be capital. Let's look at some examples. Now, given here are English names of elements. So, carbon is an English name, oxygen is an English name, and sulfur is an English name. You have to remember the spellings as well, students. But for sulfur, we use different spellings. Most commonly, we use this spelling, S-U-L-P-H-U-R. So, that is how you are supposed to write. For carbon, if you take the English name, the first letter of the name, that is C. That becomes the symbol of the element. So, carbon is given the symbol C and it has to be a capital C. Then, if you take oxygen, the first letter, that is O. So, that is given the symbol capital O. And then we have sulfur. First letter of sulfur is S. So, we give the symbol as S. So, if you know the symbol C, you know it is carbon. No confusion there. If you see the symbol S, capital S, you know it is sulfur. So, that is how we identify elements. Is that okay? So, first letter of the element in capital letters. That is the first thing that you have to remember. But then, now we came across some elements. Now you can remember carbon, copper, chlorine. All of them start with the letter C. So, can we assign the same letter to all of those? You can't. Then we have to move on to the next guideline. We will see how we do that. When the names of several elements commence in the same letter. So, as I said, carbon, copper, chlorine, all of them start with the same letter. Then, of course, the next letter or another letter in the name is added to the symbol. So, it can be the second letter or the third letter or any other letter from the name is added to the symbol. And when we do that, again the first letter has to be capital, the second letter has to be a simple letter. That is again a convention or guideline. So, in that the second letter is a simple letter. So, let's look at some examples here. Now, the elements are given, as I said, now chlorine. So, if we write C, that means it's carbon. So, then what we do is, we don't take the second letter H, but they have already taken the third letter L. So, chlorine is given the symbol capital C and simple L. Chlorine. Now, all these you have to remember, students. Once you learn writing the symbols, you cannot forget. You have to know the standard symbols. And you can't change it. You can't write a simple C and simple L. Now, you can't write it as simple C and simple L. That is wrong. Or you can't write it as capital C and capital L. That is also wrong. You have to write the first letter capital, second letter simple. Then, calcium. So, again, C, but we take the second letter A as well. So, that is calcium. Capital C and simple A. So again, it has to be capital C and simple A. You can't change that. Calcium. So you know carbon, you know chlorine, you know calcium. The similar way I told you all about copper. We will be discussing that. For copper, we actually use Cu. This is copper. This again is related to cuprum, another name that I will introduce to you all. So Cu is copper. Everything starts with C. Then we have another example, magnesium. So in this, first letter is M. Then we need to write the second letter, not A, instead G. Magnesium, G. Because there is another element called manganese that has the symbol Mn. You don't have to worry about that, but you have to remember, because there are more than one element starting with M, we use 2 letters. Then the next one, aluminium. That is given the symbol capital A and simple L. Aluminium. Because argon is another element that starts with A. So since there are more than one element starting with the same letter, we use 2 letters. Chlorine, Cl. Calcium, Ca. Magnesium, Mg. And aluminium, Al. And remember, always the first letter of the element has to be capital. And the second letter can either be the second letter or another letter from the name. Is that clear to you all? So then, I told you all this copper. Now, copper is the English name. But we have given the symbol Cu. There is no U in this name. The reason is copper has a Latin name, cuprum. So in this, you can see Cu. That is why we give the symbol as Cu. Similar to that, there are some more elements that have an English name as well as a Latin name. And some of the elements are named after their Latin names or given the symbol after their Latin names. We will look at some of those examples. In some elements, the symbol originates in its Latin name. So that is what we are going to do now. So for example, if we take the English name, Latin name, and we'll try to write the symbol for sodium. Now sodium, if you write, you have to use S and some other letter. But we don't use that name. Instead, we use the Latin name natrium. And based on that, what has to be the first letter? It has to be capital N. And then we use the second letter A, natrium. So, sodium is natrium in Latin and given the symbol Na. Then we have copper. As I told you, cuprum. So, Cu. First letter C and the second letter U. Cu is the symbol for copper because it's cuprum. Then lead. You know what lead is? Again a metal. And that is called plumbum in Latin. So, because it is plumbum, we use capital P and simple B. Plumbum. So, here it is the first letter and this letter. I told you all before, in addition to the first letter, it can be either the second letter or any other letter from the name. So, plumbum, P and B. In these two, they have taken the first 2 letters. But here it is the first letter and this letter B, P, P. Then gold is called aurum. So, there again the first 2 letters, aurum. A, U, aurum. That is the symbol for gold, gold, aurum. Then mercury is known as hydrargyrum, hydrargyrum. So, there they use the first letter H and this letter G, hydrargyrum. So, there H, G is the symbol for mercury, hydrargyrum. Then iron is ferrum. So they use the first two letters, Fe. So ferrum is Fe. Iron is Fe because it's called ferrum in Latin. Then silver is argentum. So there we use A and G. The silver is given the symbol Ag. So is this okay, students? You all have to remember the English name, the Latin name and the symbol for all these elements. So sodium, natrium, Na. Copper, cuprum, Cu. Lead, plumbum, Pb. And gold, aurum, Au. Mercury, hydrogyrum, Hg. And iron, ferrum, Fe. And silver, argentum, Ag. So those are some symbols that you have to remember. With that, I will move on to the next slide where we discuss some more examples. So several elements and their symbols are given to you. So we will try to write down the symbols here again, element and symbol. What is the first one? It is hydrogen. So hydrogen, just one letter, H. It has to be capital H. It's the English name as well. Then carbon. You're familiar with that? English name, one letter, capital C, carbon. Then oxygen, again one letter. It's again the English name and we use the first letter O, capital O. Then nitrogen. That is also the English name and we use the first letter only. Nitrogen is capital N. Sulfur, again the English name and we write the first letter S, sulfur. Then we have chlorine. So already we have carbon there. Chlorine also starts with C. So I told you all we use another letter. Here it is the first letter and the third letter. So that becomes capital C, simple L, chlorine. What about aluminium? Again, there are elements starting with the letter A. So we wrote A, capital A and simple L, aluminium. So are these okay, students? Hydrogen, capital H. Carbon, capital C. Oxygen, capital O. Then we have nitrogen, capital N. Sulfur, capital S. And chlorine, two letters, capital C and simple L. Aluminium, capital A and simple L. So as you look at these elements, you should know, okay, if you look at this hydrogen, carbon, oxygen, nitrogen, sulfur, then chlorine and aluminium. You all have to remember that. Then I will move on to the second table here. So that also has some elements. First one is magnesium. We have already written the symbol, capital M and simple G, magnesium. So M and the third letter G. Then we have zinc. That also needs two letters. So that is written as capital Z and simple N. First letter and third letter, zinc. Then we have silicon. Already we have sulfur. So we need to use two letters, first two letters. So silicon is Si, silicon. Then phosphorus, it's only one letter, phosphorus. So these are again all English names. All these are English names. Phosphorus, P. Then argon. I told you all when I discussed aluminium, argon starts with A. So here we give the symbol AR. We don't just use A, we use AR, argon, first two letters. Then calcium, we already wrote that, Ca, capital C, simple A. And iodine, that again is just one element and only one name. So we write the letter I, capital I. Is this okay, students? So by looking at the symbol, you should know Mg is magnesium, Zn is zinc, Si is silicon, P. Phosphorus, Ar. Argon, Ca. Calcium, and I. Iodine. So, these are the symbols of elements that you need to know. You should know whether it's the English name. If it's the English name, we use the first letter. It has to be capital. And if there are more than one element starting with the same letter, we use the second letter in addition to the first letter, or another letter from the name again in addition to the first letter. Then we write the first letter in capital, and the second letter, whatever the letter we are using after that, has to be a simple letter, like here. Say for example, capital S and simple I for silicon. Then there are elements that have the English name as well as the Latin name. Then we use symbols from the Latin name. Then also, like for sodium, natrium, what we do is we use the first letter and the second letter or another letter from the name. That again, the first letter has to be capital. The second letter of the symbol has to be a simple letter. So, you have to remember all these guidelines and you have to remember the way of writing these elements. So, this is a table that is there in your textbook as well. So, I hope you can understand how to write the symbols for elements. So, okay students, now you all know how to write the symbols for elements. So, we started the lesson by discussing what matter is, then how we can classify matter as pure substances and mixtures. Then we did some activities where we classified pure substances as elements and compounds. And then you try to understand what elements and compounds are. And thereafter, we saw how we can give symbols to elements. And those are internationally accepted symbols, or what we can call as standard symbols of elements. You have to write them as they are. So, with that, I am going to end this chapter. In the next chapter, we will be looking at the constituent particles of elements. Those are the atoms. And then I will discuss the structure of atoms and what compounds